Hey, what's up? So welcome to the first edition of Tinker Talk. This is a bit of a long version. I've got a bunch of stuff to go over. This is where I'm going to just try to keep everyone up to date on the little projects I'm working on. Not necessarily the useful ones. Things I guess fall in my own trap here. Fall more into the cool category rather than useful. But projects that we still end up cutting our teeth on, really learning about, and learning how to build those bigger useful projects. So um, I'll put timestamps down below in the description so you can use that to breeze through any projects that you think might be interesting to you. And yeah, got a lot to look at, so let's get at it. Alright, so I've been really interested in hot air engines lately, and so I've been just building these little models to explore how they work and how they function and what I can do to build some around the house with materials. Maybe buy a couple materials, but try some models first. So I really didn't expect these were going to work. This was just the initial. Wanted to try the crankshaft mechanism you see so often on the pop can models and stuff, and it does work pretty well. It's pretty functional. Of course, the rest of it didn't work, and these were all designed to be low temperature differentials, right? They've got the big displacers. I didn't use the candle power ones, so I might actually build a candle power one. Now that I've built a couple that didn't work, I just want one that works. So this is the next step up. I wanted to try they call it a Ross yoke. This mechanism here with this stabilizer bar. I'm missing a bearing, so I'll just hold on to it. Just don't pay attention to that diaphragm there. And that mechanism was supposed to just drive two pistons, right? So these would be the drive points for the two pistons, and then you can arrange it different ways. You can really tweak things out with this stabilizer bar here. And I also played with building a separate lever over here, and then levering off of one side of this yoke to change the stroke depths for the various pistons. But yeah, it didn't really work as a motor. I did make up a cheap little displacer and stuff in here, but it fell off the rod quickly, and I really didn't expect it was going to work very well. It was just a hollow can. Alright, and here's the next incarnation air motor. Use the same mechanism, changed it around a little bit. I've been playing with the offset, trying to change the stroke depth and stuff. Doesn't work. I was really focused on the mechanisms for this motor and didn't do a single calculation for air volume or anything, which is the important part for these motors. You really have to, like, the air volume calculations are what makes these motors run. They run in a very specific set of conditions, and if you don't hit that, then it doesn't work. So it failed as a build, but I succeeded in learning what I wanted to and about these motors, and you know, maybe I'll go through and do another one later. But there are lots of parts on here I'm going to use still, of course. A little bit about it. I did the chamber out of wood and then aluminum. The aluminum is a bit thin, so it was, even if I had got it to work, I would have lost a lot of compression. As you can see, it's moving there. But this worked because I overheated it. I got mad and put it on the gas stove and just heated the hell out of it. Let's see, the diaphragm, I used a condom. It actually worked really well. So at one time I had the stroke a lot more, and it flexes really nice. But again, because it flexes so much, it might lose compression there in a proper build. So I don't know what else. This little piston turned out to work really well. Really low friction stuff. This one never really got attached, but I did mill the bottom of it so it would stick in the hole there a little bit better. And then it can move around just to align that displacer piston a bit better. So, success and failure. So I'm not going to be able to use this design for what I want to do. So I'm just testing motors to see one. I need something that works not under perfect conditions, right? Something that's going to be somewhat useful and not so picky. I need a reliable hot air motor. I want to see if there is one out there that exists. So this one, I kind of started off on in a weird spot there with that. So what else have I got? This leads me to this other project. I haven't really talked about this one a lot. This is a levitator project. I wanted to get this going really bad, and started off this year by getting kicked in the butt by a friend to get it going, and very thankful for that. So, you know who you are. So it's basically like a magnetic bearing, like you would see normally, right? With the two magnets on the bottom, one magnet at the top, and then you have a pin on one side, and then both sides are levitated by the permanent magnets, and then kind of rest on a pin point, which you would put on glass or something low friction, and it would spin. I wanted to have no friction, so I put coils on the ends with linear Hall sensors, and built this little circuit and stuff here to sense where this is. It's not hooked up right now, so I'll put a little link of it working here. And so now it's not working as well because I was trying to make it adjustable, and because I put two sensors in here, two inputs on the Arduino, it slows the sketch down a little bit. Like what is it, a 16 megahertz processor or something? 12, I can't remember what it is. It's not a very fast processor, so I had it doing very few functions with no delays, and then it was running fast enough to operate to actually levitate this. But with the additional functions, it's a little bit too slow. So it's just a kind of a fun little project. Someone could take it from here. It's all documented. It is documented online at Russ's forums at RWG Research, open source research. And yeah, I'll put a link in the description for where you can find that. And so I think what I'm going to end up doing with these two things is kind of mashing them together into a solenoid motor, something I've always wanted to do. And because of this Ross yoke and all the mechanisms here, I'm happy with how they're working and stuff. I'm going to use this Ross yoke and put two coils down there and try to build a little solenoid motor. So I might use this circuit, but I might actually build a different one with an H-bridge so I can pulse those coils two different ways. So I don't know, I got some stuff in my head, so we'll see what happens next. Okay, and if that wasn't enough, I've got this project on the go as well. It's actually been about a month or so since I've touched this one, but I'm going to have to get back to it. The idea was to test out these Lily impellers as a drive. Where's my large one that I've got here? But yeah, as a drive source, as a source of propulsion, right? So, printed up this large one and tested it out. Wow, it's got a lot of pull once it gets the RPMs go up. Huh. Cool. I just wanted to test it as a propulsion device in some kind of craft. Let's try it out. Oh, there it goes. Look at him, he's got a curve to him though. So I went way overboard and started 3D printing this jet boat. Now it is working. Battery pack is disconnected. It's got the inlets at the bottom. And then the Lily impellers are here, forcing the water out. Two printer motors. All the circuit is all in here. There's a nice H-bridge and what was it, an NRF something chip for the Arduino, which goes over to this guy, so I can remote control. And I'll have a couple different sensors and stuff. So much like lots of these projects, if anyone has any questions about any of these things, or you want me to go into more detail about different things, just let me know. Hey, what's happening? So just a quick little bit about the process it took to make this little project, a little trick I've been using. So you don't see this very often on YouTube videos, all the failed prototypes. There's even more downstairs, and the work it takes to put into making a 3D model of a project that you want. Like when you really have an idea of something you want to build, and you're trying to work it into existing parts, you know, bearings, magnets, you know, whatever you've got that you're trying to work it in. So I found this was really handy. I printed up some of these. I'm going to redo them with the actual measurements printed and raised on it, like this kind of. So these have been invaluable for this project for fitting different things. And it's, you know, not everyone's printer is the same, not everyone's filament's the same, your parts are different. When you really want to pressure fit parts, this comes in super handy, right? So now, like, this is pressure fit on there, nice and tight. I don't even want to take it off really, because it's super tight in there. The magnets are super tight. And so, oh, I'm getting stuck to everything here. Jeez, look at this. And so now I've come up with something like this. This I just took off the printer this morning, and this is beautiful. It's exactly what I wanted. So I've got 4 different sizes of magnets on this project. So I've got 1, beautiful, and this took so much work. 2, come on, you can get in there. Oh yeah. 3, yeah, I tested the other side, but I haven't put them in this side yet. So this is not even cleaned out or anything. This is just right off the printer. And these little guys. Oh, that one's a little bit loose actually. I'll have to put a spot of glue on that. But yeah, so it took a lot to get it so that it's nice and fit like that, right? So, and then they've got little holes in the back. I've got to clean these ones out so you can see them, so I can push it out or whatever. So I'll make these files available online somehow, probably on Russ's forums or something like that. But not everyone will have the same magnets, right? So lots of different projects, and that was awesome. So there you go. Cheers. Okay, and here is the beginning of the new control panel for my solar house. Upgrading from an Uno to a Mega. It's going to double the analog inputs that I've got, so I can get twice the temperature sensors in there. And I'm just designing little headers and things. I usually use these little filter caps, anywhere from 1 microfarad to 10. These are 10 microfarad caps. Those might be a little bit large, but I use those to steady the signals coming into the analogs. I'm running, you know, anywhere up to 15, 20 foot lines out to temperature sensors, so things get a little jittery, so I use the software and the filter caps to smooth out the signals, and it works pretty well. I basically realized what I'm building here. This is a control panel for a commercial, or whatever you want to call it, irrigation system. So professionally made control panel controls all your irrigation in your lawn. That's essentially what I'm making here, to control the solar running. And then I got thinking about how much I've actually put into my system. Some people might want to know how much it took to get things running. And excluding the tubes, so that would be the collectors, without the collectors, everything that I've put in to get the system running is under $1,000 to get solar heat into the tank. Now all the underground storage is added onto that. But that's pumps, controllers, tank, lines, insulation, everything was probably about $800 that I spent, plus the collectors, and I'm collecting solar heat, so, and controlled. So this, as an idea, there you go. Oh, what the hell. Here's a 40 volt teaser. Let's turn the power up a little bit. Go from 5% or so to about, I'd say 20% duty. Oh. Change frequency a little bit. There it is. Alright. Still no heat sinks, and that's just the little guys. So let's get playing later on tonight. Cheers.